We want to consider the polar equation r of theta is equal to 3 theta plus cosine of theta for 0 to 2 pi. And we want to find out what dy dx is at theta is equal to pi over 6. So if we were just to use this without a calculator, I got to figure out what r of pi over 6 is. I got to figure out what r prime of pi over 6 is. I got to figure out what cosine of pi over 6 is, and I got to figure out what sine of pi over 6 is, so that I could plug everything I know here. So for r pi over 6, that is 3 theta, so that's going to be pi over 2 here. And then cosine of pi over 6 is root 3 over 2. So this tells me that r of pi over 6 is pi plus root 3 over 2. Now, r prime of pi over 6, I got to figure out what that is. I got to take the derivative of that. That is going to be 3 minus sine of theta. If I were to plug in sine of pi over 6, that's going to give me 1/2. So that's going to be 2.5, which is going to be 5/2. All right, and we know that cosine of pi over 6 is root 3 over 2, and sine pi over 6 is 1/2. Now, we want to find dy dx, so of course we are going to say dy dx is equal to r cosine of theta plus r prime sine of theta over negative r sine of theta plus r prime cosine of theta. All right, once we do that and put this into the handy dandy calculator, we are going to get 3.5497. All right, so that was number 1. Part A. Part B says find the area of the region of the second quadrant bounded by the coordinate axis in the graph of R. So thinking about the second quadrant, remember that's going to be pi over 2 to pi. So here, that's just going to give me 1/2 pi over 2 pi of 3 theta plus cosine of theta square d theta. So once we do that, I'm going to get the area being 33.376. Now, what I'm also going to do here is actually put this in my handy dandy calculator so that we can look at that. We have mode, polar, erase that, 3 theta plus cosine of theta, and changing my windows because this is from 0 to 2 pi in terms of my theta. Graph it. Probably need to zoom out, so I'm going to do window, actually no zoom, and I'm going to actually zoom fit this. So oops, okay, just kidding. We are not going to zoom fit that. We're going to do, let's say, -5 to 5, and we're going to say -5 to 5. Then let's see what happens there. Okay, because remember, the only thing I really want is the second quadrant. So here, I am going to actually, let's do 8 here, and let's do 0 here because I only want the second, no, -1. So I want the second quadrant. Here, I am going to do 0. Then let's see, -10. Okay. Now, I gotta figure out where I'm starting at. Since this is the second quadrant, this is going to be pi over 2. So I have pi over 2 up there. And if I were to do that, it's going to give me this region right here. So if I were to do that, that's going to give us 33.376. Also, a little tip here for part A. To find dy dx at theta is equal to pi over 6, what I can do also here is use second calc and click on dy dx, find dy dx at pi over 6. And notice how they gave you that to be 3.54972, which is what hopefully you guys got whenever you did all of this right here. Crazy, I know. I'm going to gatekeep that, so if you do watch the video, congrats. If you don't, well, if they don't, well, sucks. Okay. For C, for pi over 2 to pi, there is a point P on the polar curve R with our y-coordinate 1. We want to find the angle that corresponds to the point P, and then we want to find the x-coordinate of the point P. So we have y is equal to r sine of theta, and that's going to give me 1. And r, remember, that is going to be 3 theta plus cosine of theta, sine of theta, and we got to figure out what theta is from pi over 2 to pi. Now, once again, I am going to put this in a function mode, and I am going to go ahead and erase everything here and put in what I have. So my intersection is going to be 1, and then we have 3 theta plus cosine of theta, and then that's multiplied by sine of theta here. This is from pi over 2 to pi. So I'm going to change this to be pi over 2 and pi. We also want to make sure that since my y-coordinate is 1, I have it so that's between -1 and 1, let's say, or 2. Graph it. Find my intersection by doing, oh, great. Love another add. Okay, this is going to take a minute. Okay. There you go. So we have my left bound right here. Oh, my beauty. And that's going to give us 3.017 as my intersection. So theta is equal to 3.017. And it tells us to find the x-coordinate of P. So x is going to be our cosine of theta. So the only thing that we're going to do here is just, instead of sine, we have cosine. So the value of x is already saved for us. So what we are going to do here is just go ahead and do 3x plus cosine of x, and then this is cosine of x. That's going to give us negative 7.997. Negative 7.997. All right, last one for this video. I don't even know how long this video is going to be. A particle is traveling along the polar curve so that its position at time t is x of t, y of t, and such that d theta dt is equal to 2. We want to find out what dx dt at the instance when theta is equal to 5 pi over 6. And we want to interpret our answer in context of the motion of the particle. Okay, so we want to figure out what dx dt is whenever we have 5 pi over 6. Well, dx dt is going to be equal to dx d theta times d theta dt. And of course, we want all of this to be whenever theta is 5 pi over 6. All right, so what we have right here is d theta dt being 2. So I could probably cross that out and just say that it's 2. And then I need to figure out what dx d theta is. Well, to figure that out, I already have x right here, 3 theta plus cosine of theta plus times cosine of theta right here. So what I have to do really is just take the derivative of this at 5 pi over 6 and then multiply that by 2. So I have that right there. So what I'm going to do is math nth derivative of this right here, and that is 5 pi over 6. And then I am going to multiply by 2, and that's going to give us our answer of negative 11.318. Negative 11.318. So that is dx dt. So this means that the x-coordinate of the particle is decreasing at a rate of 11.318. What's our units? Radian per time. Or just say 11.318. Since we don't, it's not radian because this is in terms of x, and we don't know if this is meters or, feet and whatnot. So just have units of time here. All right, in the next video, we will do 4 through 6 with FRQ practice.